Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we are going to finish our array-based queue. We started in the last video and we started our development using what's called test-driven development. So the idea was that we made a very basic implementation of our queue and we weren't allowed to add anything to it until we had a test that failed. So we went in and we started adding tests one at a time until we built up our functionality in the queue. The last test that we were working on was this one, which enqueues 100 items and then dequeues them, peeks at them as it's going, and this fails. And it fails because we have the same problem we had with our stack, where our array only holds 10. It fails in a different way because our queue is circular. It uses modular arithmetic to wrap back around. But when I add this many, I wind up overwriting multiple times. So to figure out how we're going to fix this test, we should go back kind of to our starting situation and maybe see what happens if we do. Actually, I'll do this, make this a little bit shorter so it's easier for me to do this example. We start off with 5 elements here, and I enqueue a 5, and then I enqueue a 3. Now if I dequeue, the front of the queue moves up. Now let's say I enqueue a 1, and then I enqueue a 9. Now I do a dequeue, and the front moves up. Once again, I'm not blanking these values out, but they would be rewritten later. Now I enqueue another value, let's say a 7. At that point, this wraps all the way back around to the beginning. If I then enqueue a 2, we get to this situation, and now let's say I call enqueue one more time. Well, first let's see what would happen if I do the code that I have right now. If I call enqueue one more time, and this is what's happening in that test, let's say I enqueue an 8, I get to this situation right here. Now technically I haven't overwritten anything bad yet. That 3 was something that had already been dequeued, and so I didn't really need it. However, when you look at this situation, you might notice there's a problem here. The back and the front are equal, which means that even though technically my queue is full, it has 5 elements on it, when we call isEmpty, we will get back true, which is not what we want. Okay, so before I can push this, before I can enqueue this 8, I need to grow the size of my array. Okay? And I have to do more than just grow the size of my array, because if I just grew the size of my array and copied everything over, I would wind up with something that looks like this. Well, that's a little bit of a problem, because now I have the front is still here, and so starting at the front of my queue, I now have 1, 9, 7, followed by 0, 0, 0, 0, 0, followed by 2, and then I would wind up putting the 8 here, and I'd still have front and back equal to each other. So that really doesn't help me. I need to make a bigger array, that much is definitely true, but I can't just copy the elements from where they are and leave front and back where they are. I have to copy things around a little bit differently. And so to illustrate this, let's go ahead and let's say make my larger array like that, and then I want to copy things over. Now there are lots of different ways that I could do this. The way that I prefer to do it is to actually start at the front and copy it down. So the 1 goes to there, the 9 goes to there, the 7 goes to there, the 2 goes to there. I actually don't copy the 3 because it's not a real element at this point. And then my back is here, and my front is here. Okay, and so I'm left with this situation on my queue. This is what I want to write the code to do. Okay, basically to move the front to the very beginning, and then to copy all the elements that are in there that are real, so the back is here. And now if I were to complete the enqueue of my 8, everything works fine, and I don't have any problems. So let's go look at how we put this into our enqueue. So just like before, with the stack, I need an if check in here. What am I checking for? I'm not checking for back is equal to front, and I also can't check for a simple back plus 1 equal front. Because what if the back had been here on the 7 and the front had been on the 2? Well, then enqueuing would still cause this to wrap around. This is part of why I like to use the modulo arithmetic, because what I really need to do here is this. If I were doing this with a, oops, that's not a B, that's back. If I were doing this not with modulo arithmetic, but with ifs, it would be a lot harder to write this because I need an if inside of my if. The modulo arithmetic makes it very easy to express that. We'll also see in just a second part of another place where I like to use the modulo arithmetic. So I'm going to create my temporary array again, and it's going to be equal to a new array of type A. And once again, I am going to make the length of it as data.length times 2, so that we have this amortized cost, so that while every so often it has to do a bunch of copies, on average, everything is order 1. Okay. And I will wind up finishing off saying data equals temp. But now I need, and let's make our data a var again. Now I need to copy things over. So I'm going to write a little for loop. I am going to have I go from 0 until data.length -1. Until and -1 because, as we saw, in this situation where I had 5 elements, I don't actually need to copy 5 elements, I only need to copy 4. And what I want to do the assignment of is I want temp sub I to be equal to data sub, well, it's not just sub I have this offset of whatever the front was. So I plus front. But the problem is if I just do that, then we're going to wind up accessing out here past the end of the queue. So once again, I am going to resort to my modulo arithmetic and do that. Okay. Here again, I could have expressed this with an if, but the if would have been a bit more complex. Okay, so this makes the new array and it copies over the values. So if I undo my enqueuing of the 8 there, I have this array when I'm done with that. I have copied the 4 elements over, and they start with the element that was at front goes into position 0. I set this to be my new array. The last thing that I need to do is I need to reset front and back. So front, the way I'm doing this, always moves down to 0. And back, well, what does back move to? I'm going to do this before I change my data, because where back is depends upon the data.length. So here you can see my original data had a length of 5. I want this to be on index 4, and that is the general formula, because I copied, if I had copied across 5 elements, I would want it to be on or if I had copied across data.length elements, I would want it to be at data.length. But I'm always copying 1 fewer, so I go to data.length -1. Let's try it. So if we come back over here to our test and we run it, green bar. Okay. And we could put in, once again, a lot more tests in here, try to do whatever we can to break it. I think the ideal in your test-driven development is you want to test everything and you want to do as much as you can to try to break this, because these tests are the things that give you courage so that later on when you start changing things, you know, hey, if all of my tests pass, I feel comfortable that the changes I've made are still resulting in working code. But for our purposes here in this video, we're going to stop now and leave it with this implementation as it is. So that's it for this video, and we'll see you again soon.